Let's investigate another property that logarithms have that stems from the logarithm being the inverse of the exponential function. So let's recall that for functions and their inverses, f inverse of f of x is equal to x as long as x is in the domain of f, and f of f inverse of x is equal to x if x is in the domain of f inverse. So if f of x is b to the x, well, that would make f inverse of x log base b of x. Then this first statement would be that log base b of f of x being b to the x, is equal to x for all x in the domain of b to the x. And the domain of b to the x is all real numbers. So this would be for all x in minus infinity, comma, infinity, or in other words, it's just true for every single x value. The second statement here, that f of f inverse of x equals x, would be that b to the log base b of x is equal to x. And this is going to be true for all x in the domain of the inverse function log base b of x. And the domain of log base b of x is all the positive numbers. So this is going to be true for all x bigger than 0. This fact allows us to evaluate compositions of exponentials and logarithms very quickly. So for example, we can evaluate 2 to the log base 2 of 7, even though we cannot evaluate log base 2 of 7 itself without a calculator. We can evaluate 2 to the log base 2 of 7 using this second property here, that b to the log base b of x is x. So whatever is here will be the answer. This will be equal to 7. One thing that is tempting to say would be that 2 to the log base 2 of negative 7 is equal to negative 7. However, this is not true because negative 7 is not in the domain of log base 2 of x. So this actually does not have an output because we cannot evaluate log base 2 of negative 7. We can also say things like log base 2 of 2 to the 7 is equal to, well, log base b of b to the x is going to be x. So in this case, log base 2 of 2 to the 7th is 7. Also, log base 2 of 2 to the minus 7 will be equal to minus 7. Remember, in order to say that log base b of b to the x is x, x has to be in the domain of b to the x, which is any real number. So we don't have the same hindrance as we did with this example. We can do log base 2 of 2 to the minus 7, and that answer will be negative 7. One more thing about this that I'd like to quickly point out. In order to use this property, the bases do have to be the same. So if you had something like log base 2 of 3 to the 7th, since the bases of the logarithm and the exponential don't match, we can't use this property to evaluate log base 2 of 3 to the 7th.